If you have questions around manufacturing, come see me afterwards. I'm going to keep this on the AEC. Does that make sense for everyone?
Yeah.
Anyone have a 3D printer now?
Actually, yes. You said that I was looking for you.
Oh, yeah. Is that, but you do have a 3D printer?
In our New York office.
Yeah, what kind do you have? Oh, you don't know. All right, so it's a good start. But anyways, all right, so I'll get into it. I won't go. We'll keep it short and I'll get into it. So the first thing I always like to do, because there's so much in the news, is just define 3D printing, right? And it really is about adding material versus subtracting, right? Think in the manufacturing world, most of the time what we're doing is we're subtracting from a block of steel, and then we're using the mold into that or that type of thing. But the advantage of 3D printing is less waste, right? And the fact that we're adding materials. There's two really ways that we 3D print today, right? The first one is, anyone familiar with FDM? Fused deposition modeling. It takes a spool of material, right, and then melts it through a glue gun. And think about it. Now we're doing things like chocolate. We're doing pizza. Exactly. So that's kind of one way. The other way is to take a powder and then kind of bind that powder. There's a couple ways to do that: through an agent, right, or through a laser. That's how metal printing is done, right? Which is, again, kind of on the cusp of really being used. Now, in our world, in the building industry, we mostly use them for models, but not that much. But at the very end, I'll talk about the future and how I see it affecting some of our business. So, but what are the advantages in the realm? And again, it's probably more been on the manufacturing. It streamlines production, right? Think of the challenge of creating an iPhone case the first time. You got to create tooling. You got to, create the line. And 3D printing, you just print it, right? So it totally streamlines the ability to manufacture a good. And that's the good and bad, because your cost to print one is the same as 1,000,000. So that's why we still do it. Obviously, customization. 3D printing is allowed customization. Invisalign. Every Invisalign is actually 3D printed, right? They're taking the scan data of your mouth. They got software that interprets how the teeth have got to move. But 3D printing is allowing us to customize things, and I think that's where we're going to see some things in our field in the building industry, as far as really doing some unique things in the way we live, healthcare, that's going to affect the way we build homes. The other thing on a positive side is we are seeing more jobs come back to the U.S. because we're designing quicker, right? I just made a call with Bosch Tools. Do you know that they have an 8-month cycle for new tools? To me, that's a phenomenally fast when you figure out where they were going. It used to be 17 to 18 months. So what's helping us is now that some of that manufacturing comes here because they can't even wait for it to come across. And then I talked a little bit about the economics of production. As I said, you can print something the same price as $14,000, but there's advantages here, disadvantages there. But I always like to say, heads up, there's a lot of exuberance. We'll talk about the future of 3D printed houses. Man, we are way down the path. Even metal printing. We sell metal printers, and we've had good success with it, but it's small, very complex parts. CNC is still going to be here. So I always try to do that. You read a lot. The cube that we're printing in downstairs really is kind of a piece of crap, right? You got to be a hobbyist to get it going. Now, it's got its place. It's really cool, but you got to be careful in what you're reading. Kevin and I were talking about this. They show examples of these high-level, images printed on these entry level. It's just not possible. And there's still a disadvantage is the materials, right, aren't as robust as traditional manufacturing. That's why it hasn't impacted our business as much, because you're somewhat limited. They're generally acrylic plastics, low heat temperatures, that type of thing. So this is just another summary. Why are we using it? Is because we can do more complex, more unique things. But there is still a place for traditional manufacturing. And traditional manufacturing, in the realm we play in, is still geared towards larger parts, right? Take Boeing as the anomaly. They print some wings, right? But they have a $50 million machine that does that. Size becomes an issue. Most of what we're doing is in the small space. So, but I think you all know the ranges of application. Automotive's been using it, but really in our space, it's mostly been used for model, and even that we're a little slow, I think, in doing it. So, Kevin and I are talking about scan data, and it's one of the reasons that we're so passionate about built worlds, right? Think about how our world is changing. Manufacturing's been living in the 3D design world for 25 years, right? And it's affecting our market space because now our data is different. We should be building buildings different, and that's why we're here this weekend, right? Figuring out how we can leverage that. But 3D printing and 3D scanning is just an extension of why we should be using these technologies. And the other thing that we see, so in our business, we cover both manufacturing and building. You know, it's converging, right? Now we're taking building products and building them, you know, virtually into our buildings. So, you know, anytime we're talking about 3D printing or 3D scanning, it's not a gimmick. You should be thinking about the ways that your workflow, that you do it today and the way you should be doing it in the future. So we just kind of talk about how are you using it, 3D data, but we think, you know, you should be using 3D models and 3D scans. It's probably not represented there. So traditionally models have been built, they communicate better, right? How many times are you presenting an idea? People just can't get even rendering sometimes, right? I mean, it's very hard for people to make decisions. Interactivity, right? We take what the Architectural Institute does with the whole city. Having a model in your hand allows you to spin it, to look at it, and really get a better perception of it. And then, of course, understanding design intent, which we'll talk about. So, I mean, today, it's funny, we're still predominantly, I would say 80% of models are still hand-built, right? Laser cutters, X-Acto knives, that type of thing. But it's amazing me how long we spend building models when we can print them overnight, right? And so that's the advantage. Now we can print this type of objects to actually show and represent what we're doing. So let's talk about 3D print technologies. I hit it, but just to give you a high-level understanding of how we view 3D printing, right or wrong, we bucket them in 3 categories. Take this first desktop, that's like the CubeX downstairs. So the reason desktops have exploded, FDM, the patent expired, right? So now anyone can make it. In fact, Dremel, who's Bosch, that we sell 3D printers to, has their own 3D printed tool. And then now where we've really affecting is this professional. This is that 50 to 150,000, and now you're getting good quality parts. If you go down to our table down there, you can see some of the models built. This has been the biggest change because now instead of $500,000, you can buy powder-based printers or even acrylic plastic type printers that give you high quality type images. And then of course we still have production, and that's just kind of the set where it's at. So I won't get too much in depth to the hobby, but you can go down and see the printer. MakerBot's probably the most famous, but again, all it does is it takes a spool of material, melts it, and just adds it on, right? And kind of builds it. So very simple, very straightforward, but very limited, right? Failure rate's very high because the environment is in control. So as plastic cools, it has a tendency to warp, right? So they just have a high failure rate, but again, they do have their place. They're kind of cool. They're great for education. They're great for, again, hobbyists, and again, for certain applications. So I won't get into that. But the professional is really where it's changing from a model perspective. Is anyone familiar with Z-Corp or powder-based printing? Good or bad experiences? You can be honest.
Well, I didn't use it personally.
So there, a lot of people had bad experiences with it when it was new. But basically, when you're 3D printing, you're taking a CAD file and you're just splitting that into layers, right, for printing. And in a powder-based printing, what it does is it lays a very fine 4/1000ths layer of powder. It comes through with a standard HP ink head, but instead of ink, it actually jets a binder. And it solidifies it where it needs in that layer. Another layer, it just continues that process until you're done, and then you pull it out of your powder. One of the advantages in our realm to create models is anytime you're 3D printing, if you're printing an angle, you obviously can't print it in air. You need a support structure. In most cases, it's a different type of plastic or something that you break off. With powder, you can actually just blow that powder away into the support and reclaim it. So you can do complex geometries, buildings type things. And this, I'll show you a video of this since this is a bigger machine. But you can see where it just takes, oh, it's got that internet audio, but it just takes that bike seat, does it in layers, and just builds it into the powder layer by layer by layer. And then in the end, you just pull it out of your powder, blow it off, infiltrate it with C8 to give it some strength. And now these parts are very strong. Back about 8 years ago, the machines were actually starch-based. They were really brittle. How long? I don't know if that's what it is. You could almost hold them in your hand. Now they're pretty strong. In fact, they're so strong that you can actually epoxy them and you can make skateboards out of them. Some people make cyclones out of them. So they're strong enough to kind of drill and tap. But you can see in the AEC space why this works so well is you can do very complex, MEP type applications. You can do buildings, right? And it has the ability to do full color because as it's laying the binder, it can actually lay color. The other thing is it's in the 3D print realm, it's very fast, right? It prints about 1 inch vertically an hour, which seems slow, but in the 3D print world, it's 10 to 15 times faster than most others. And because you're building in a powder, like if you look at an extruded, I can only print one part at a time. Now I'm printing it layers so I can print multiple parts. So take Getch here in the city. They actually can build 3-foot towers by building in sections and assembling. And I just talked about misperceptions. The machines used to be really difficult to use. You'd have to depowder them into a vacuum, dump that powder into another, back into the system. Now it's all self-reclaimed. And again, very strong in places. So where are the applications? Again, really digital design, right? The other thing we always like to point out is when you're hand building a model, there is some interpretation by that modeler, right? But when you're actually 3D printing it, you're using the true CAD data, right? So you're getting a true representation of what your design is going to be. Because it's directly linked to the data, and the quality's been better. But we see it a lot for like early massing models, right? We see it for detailed design. You can see there's a home builder in New York, right? High-end home builder. So before he builds a home, he actually 3D prints it. This is actually like an auditorium. Like at one point, we had printed out a full-scale store for Crate and Barrel, and as they were developing the store, they'd almost assemble it just for kind of collaboration. I think Kevin's got probably better visualization and collaborative tools than that, but it can be used for that. And then just scaling the models, right? You can actually create smaller parts and assemble them. I kind of run through some of the other examples. I was talking about early massing models, right, to show that in the AEC space. This is a family portrait, right? So think you can go to a client and you can give them these 7 representations of how the building may look. That's kind of the urban setting. And all this is done in powder. This is another one where it's actually phasing of a campus model. We actually did something for this at University of Minnesota. This is not it, but it's something similar. You can see, because you can color it, you can actually, again, show the different phases actually in the print. This is a soccer stadium over in Europe that they're building again with a roof that's going to be retractable, so they can print something like that. Again, and all this can be done in under probably about 3 hours, right? Very fast now as far as printing. And again, the key thing is you can print multiple iterations of it. Where this is more applicable to like manufacturing is let's say you're going to do a different facade or maybe even an existing facade that you scan. You can actually print those out, show them, get an idea of what that construction is going to be like. Another connector study type thing, some construction nodes. MEP is a big one just from a representation perspective, right? And the key thing is we can actually keep the color, right? Maybe run the red for hot, whatever it might be. This is for Veolia, actually, locally. That's a plant that they have. Buildings, you can actually do some creative things. So we do see times where traditional model making still works, right? You want to put in trees, lifelike trees. You can actually do that, maybe do some lighting. We see that often that it augments traditional model making. This is actually kind of, again, using that tree. This is a train station, again, I think in France or somewhere like that they showed that. So the other thing that the resource, now pretty much anything you design in 3D can be printed, right? Google SketchUp is huge. Autodesk came out with Fusion, if you see Formit. So you can pretty much outdo it. There is a cool site, this 3DM TPUSA, it's like kind of a long name. They'll actually take your Revit file and get it print ready. So obviously one of the challenges we have, if we take a 5-story building and we're scaling it down, the features are sometimes an issue. In order to print, you got to thin them up. They will actually have an algorithm that gets that file print ready. It's kind of cool. It's a charge, it's pretty nominal. And I have some resources. My business cards are down there. We have a Google SketchUp white paper and a Revit white paper that if you are going to 3D print or look at it, tells you what you need to do. But what's the future? A lot of people ask, where we're going. In 2016, HP is going to be launching a 3D printer that I actually think I can talk over. But what they'll do, look at what they're doing. They're actually lifting a car, right? This technology that they're coming out with is going to be 10 times faster than anything today, and it's going to be stronger, and it's going to be about a third of the cost, is what they're saying. But now think about a construction site. If this truly can do it, right, and you need some type of fixturing, you need some type of hook, and it's strong enough, now instead of waiting, running to the supplier, you'll be able to print that. I believe someday that is going to play. And down the road, their map includes metal, right? So they're using a totally new print technology out there with some phase change and some, they're actually using agents. So now you'll be able to have that at a job site and be able to print something down. Print some out. You've probably seen the 3D printed houses, right? Think of that extruder. They're actually extruding. Does anyone know what happened in China like a month and a half ago? You can.
Well, they built a mansion and some buildings and all that.
So they built like 10 structures in a matter of 2 days, right? So again, it's kind of gimmicky. Oh, I don't know if it's running. Kind of gimmicky, but it will do it. There is printed foods. I just, again, think about that in the way we're designing houses. But one of the things I think when we look at the future too is the future home. And this is where our industry is going to change. In fact, the Museum of Science and Industry is doing a home. It's called Home 2050. And so it's interesting, when they're working on that project, our homes will not be the same in 30 years than they are today. And what they foresee is you're going to walk in, something's going to scan your body, right? And you're going to get where you need iron, where you need whatever the chemical imbalance is. There is even ones where they will, when you go to the bathroom, it'll analyze it. But you'll walk in here, and now it'll print your medicine, right? It will print prosthetic devices for you. Let's say you have a bad arm, and it will print your food according to what you need. So it's kind of interesting because, again, we're not using it yet fully in our industry, but the concept of 3D printing is going to affect the homes, the buildings we build, because we're radically changing the way we do things. So the other thing that I always like to point out is Deloitte has a free resource, and don't ask me why it's free, it's phenomenal. They have a free class that is like 12-minute videos in a test. And usually they charge for their training. It's all about 3D printing. Again, Google it, you'll find it. But if you want to really know more than I know about 3D printing, go there, you can take the class, and they can walk you through what 3D printing is about. So all right, I talked about 3D printing, and now I'll get to scanning. You want me to walk through the first part and then hand it over to you, Kevin? Like you haven't heard enough? Are you guys all staying awake before the pizza comes? So why do we want to scan? Most of the time it was a study, and it might be a slide later, 49% of AIA architects responding was existing conditions, renovations, add-ons. And think about generally the way we do it, except advanced people like Pepper and others. But we start with a blank slate, right? Or we go out and measure and we try to fill it. Now we can actually scan that and design in the context of reality. The software is getting hugely better. In the last 2 years, Autodesk with Recap as a scan software, the ability to pull it into Inventor or Revit, the ability to pull it into Navisworks and do clash detection has become hugely. So now we like to say you can document your thing easier. And so the way scanning generally works is you on a tripod scanner, and Kevin will show you an example. It basically does a line of sight scan, right? And it will scan 360 degrees. There's big players like Faro, like Leica, that are out there that do this. But in a matter of like 8 minutes, it will scan 360 degrees and take pictures and overlay it, right? So now we have a high quality image, and we take multiple scans and the software will mesh it together to give us really that existing condition. So I kind of say line of sight scanning just to give you a concept how it works, and Kevin's going to show you this building scan. But you scan from multiple locations because I can't see through that wall yet, right? Someday, who knows? And I scan from the other side, and basically I stitch those together. It's so much simpler over the last 2 years, would you say, Kevin? I mean, just from, last year. So, and the other one that's just, I don't know if Kevin even knows this, but handheld scanners. So one of the challenges we have with tripod scanners, right, is that line of sight. So Faro just introduced a low-end $14,000 handheld scanner. There's Mantis out there, but now I don't have to worry about that line of sight. I can actually take the scanner and scan this chair. So where it's really important is like MEP applications, right? Now I can scan the MEP with the handheld and then stitch it in with the tripod scanner and get one good high-quality scan in a much faster period. So I won't go through this, but just different areas. I keep talking about scanning as built, documenting as is, but you can actually do it for verification. Getting back to the parallels of manufacturing, right? Often manufacturing scans their final part and compares it to how it was designed. Now you can scan an end building and actually compare it back to the design. I think you guys do a lot of that, right, Kevin? So really validating construction. And then the other one that I believe is going to get better is now when we deliver these buildings, we're going to be able to turn over a set of data that the owners can run that building off of, right? Think about it as they go down the way, 10, 20 years later, they want to do an addition, something changes, those scanning body things come out. They'll have that data to work with it, that true as-built, to make the modifications. So the last thing before I turn it over to Kevin, he was talking about improvements, but this is how scanning used to look, right? It was low quality, I think, 2 billion points. Now we're grabbing 20 billion plus points. And what's gotten better, our computers are better, right? We can handle the data, the software can do it, but now we have high resolution, high quality, high accuracy things. So I'm going to turn it over to Kevin because I think he actually has the scan data of the building and give you an idea of what we can do.
Yeah. Hi everyone. Again, my name is Kevin Bredeson. I'm the Director of Virtual Construction for Pepper Construction here in Chicago. And I think it's important to note the journey that we've been on in terms of laser scanning. 3 years ago, I was 11 months in the door at Pepper, reached out to our president and CEO and asked him for $88,000 to go out and purchase our first 3D scanner. And at that time, it was what you saw there. It wasn't 2 billion points, it's barely a million points. We use a lot of what we refer to as reality capture, different technologies, heavily invested into the scan space. In fact, we just did buy a handheld scanner, so we're waiting. Trimble came out with one as well, the DPI. So that's going to be for us where that line of sight is too tough. We do a lot of healthcare projects. So typically when we go into that and we couple that with renovation, we can't get into spaces where we can completely demo back to structure and open those areas up so that we can scan. We have to work within the context of a ceiling, right? A 2x2 ceiling, pop a ceiling tile out, try and see what you can see, but you're limited by that line of sight. We use tripods, various ways to get our scanners up there, but sometimes the systems that are all condensed into those interstitial spaces is way too great for us to even mobilize that kind of equipment. So we're supplementing that with the handheld technology. Drones, UAVs, whatever you want to use them as, right? We're looking at that technology. We're technically grounded right now. We haven't filed for our FAA exemption yet. We're kind of seeing where the space is headed right now with rules and regs. We're planning to go in though for that kind of that exemption, trying to understand that space, trying to understand what kind of sensors can we attach to a UAV, right? Is there thermal? Is there various scan technologies that we can go and we can start to look at sites? Is there ways that we can take that information along with this information and start to look at that over time for progress? A thing that's a huge risk item, I guess, for us is when we coordinate a project, mechanical systems, what have you, when we get into validation, right? At some point that model gets signed off and somewhere that goes into a process where things are fabricated. Human hands are usually involved in that fabrication installation process, and how do we validate? So we're looking at this technology to help us validate that. And how can we take this, run algorithms and things behind the scenes that allow us to do that kind of analysis and help us out to make sure that we're getting quality built information. So this scan is of this floor. I got a little Nancy today. I went to grab their scanner, which is up and in about an hour, I shot 12 scans. They were ranging in both resolution and, well, you can see in some of the shots, some with color, some without. So we have the ability to do that. 2 scans we shot 28 million points. The rest of the 10 we shot at about 10 million points apiece. So about 160 million points gathered in about 40 minutes. And then what took me the most time was going back and trying to process that data. So those 12 scans yielded about 750 megabytes of raw data. Converted and processed, that yielded out 2.86 gigabytes of data. So that's what you're seeing here is the full cloud. Point cloud is referred to it. And you can see here through the navigation. That you can navigate that space pretty freely. And now, like Kevin was saying, you take this into a design application and use this as a background to reference off of. Now you can really build quality as-built information that you can utilize. Also, you could even utilize this as an augmentation behind the scenes. Couple this with a designed or a proposed system that might be going into a space, and now you start to see those two worlds combine and clash. To clean this up even further, our scanners and working with tools like Autodesk's Recap, you can take this and now you get a near photorealistic view, what they call, or what we refer to as a 2.5D view, and now you're into the space. You're working through the head of the scanner essentially at this point. You can't navigate freely within the 3D space, but you can use this to do all of your dimensioning. I was talking with a few guys this morning about surveying, right? How many times have you gone out to a project to survey specific information and you come back and you inadvertently just miss a few of those dimensions? Now, when you go out, you scan these kind of spaces, you can take dimensions off of almost anything. And now, I'm losing some of my tools here.
Yeah, think about
It's always good when it's
I
live.
was just say what you're doing, but piping is the big one we see, right? I mean, measure, get up there and measure that. Now, as Kevin said, they got that accurate data, right? So we actually did a project where they did it the old traditional way, and then we scanned it. And the biggest difference was not so much the square walls, right? That's easy enough, laser measurements. But it's that piping above. They actually found where they were 6 feet off in certain cases because you're taking those hand notes in a lot of cases and trying to reconfigure that.
Let me see if I can get my bearings here.
The other one, while Kevin's doing it, just to give you an idea, is we have a safety harness people for Learjet, right? So what they did, we scanned the hangar, but they used to have to go through these intricate ways of showing how theirs was safe, and they'd have to redraw the hangar. Now we took the hangar, all they did is overlay their CAD model of the racking system, right, and the pulleys and that type of thing, and they could actually do a representation and a visual of what would happen if the guy fell.
So here we are during lunch break today. I snuck in here real quick.
I thought that was real time.
So we captured a few of you here today, and taking forth the measurements. Hopefully they came through. So right there, it was just up there for a second, right? So wall to wall, we're 35 feet 11 and 5/8, right? To get to that kind of accuracy, to be able to then kind of get that information at your fingertips anytime you need it, valuable information. And again, the time to do it is really nothing. So this technology, like I said, is constantly evolving. We're looking at different ways, like the UAVs, potentially robotics, shrink down. Maybe we can get above those interstitial spaces and start to take, the various pictures and the scans that we need to take, and then supplement all of that data, and then continue to use it. So it's a vastly expanding space, and we're excited to be a part of it.